So here we're going to talk about the Diffie-Hellman Key Exchange and how it works. First of all, what it's used for is to help us transmit sensitive information over the internet because the hacker can see the stuff that's transmitted, so we have to make sure it's encrypted before we send it. So first, let's do a little refresher on modulo math. Recall that if you divide x by y, you might end up with an integer a and then a remainder of b. So for example, 27 divided by 7 equals 3, remainder 6, because 7 times 3 is 21. So you have a remainder of 6. So we say that 27 mod 7 is 6. And if we increase the number to 28, 29, and so on, we end up with these different mod numbers. Now notice that these are all numbers from 0 through 6. And when we get to 34, we circle back around to a remainder of 6. So let's take a look at this problem. If you want to solve it, it's pretty straightforward. You can do this with an ordinary calculator. But if we have x as the exponent, this is very hard to solve. And you can only do it by brute force, by trying every possible method. Now this fact is the cornerstone of modern cryptography. By the way, the answer is 31. Okay, so let's take a look at how the key exchange works. So what happens is that you and I want to exchange some information securely. So I choose a secret number and you choose a secret number. Now, we know that we're going to use these numbers G and P as part of our formula. We're going to have G to a certain exponent mod P, and we're going to do that calculation. And that is publicly known. That the hacker can see that, everybody can know that. But they don't know our secret numbers. So we calculate using our secret numbers to get the answer. Now we exchange that answer with each other. But because it's easy to go forward but not backwards, the hacker cannot figure out our secret numbers. So now we go forward and do a calculation again using the same exponent as before. And voila, we end up with the same number on each side. And that is our key. Now the hacker can't figure that out because the hacker doesn't know our secret numbers. Again, easy to go forward, hard to go backward. So the hacker is left wondering, what is that? And that's how the Diffie-Hellman Key Exchange works.